All right, so let's get going here with 6.4.
Why do we use such big words?
Optimization? I don't know, it just sounds fancy. Optimization, maximum, or the minimum value?
So the limits.
Yeah, the limits, very good. Well, because you're trying to optimize things, right? Like when you're running a business, you're trying to find out how you can make the most money for as little effort as possible, right? So this is what this is all about here.
No, on text, I guess not.
Oh, I lose where I set my I usually lose about 4 times a week.
Okay, now, with these word problems, they're pretty wordy, but they're all pretty much the same. They're going to open with a statement about what you're trying to do, or give you some context to the story. Then they're going to give you information, and then they're going to want to find the maximum or minimum value. All right? What's that? I can't remember. I'll have to double check. Okay? Somewhat similar. These ones are more like 6.3 stuff. Okay? So I'm going to do example 1 on page 325, okay? Okay? So I'm going to read it out. I'm not going to write it out. Just because it's a lot. So 3 teams are traveling to a basketball tournament in cars and minivans. Each team has no more than 2 coaches and 14 athletes. Okay? Now, each car can take 4 members, and each minivan can take 6 members. It can take 16 members. No more than 4 minivans and 12 cars are available. The school wants to know the combinations of cars and minivans that will require the minimum and maximum number of vehicles. Create a model to represent this situation. All right, so we're looking for, always read the last sentence because that'll tell you what you're looking for. All right, maximum and minimum number of vehicles. So we're looking for vehicles. All right, so X, I'm going to make that my cars, and Y, I'm going to make that my vans. Okay? Brooklyn, you need to focus, all right? All right, so we're going to work with all the information that we know about the vans and the cars. So we're going to come up with 3 or 4 equations, and these equations are known as my constraints. They'll be my lines that I draw, okay? All right? Constraints. All right, so what do I know about the vehicles?
That you need them.
Well, I know that I need them, very good.
A minivan can take 6, and a car can take 4.
Good, okay, we know that for sure too.
These are weird minivans.
Well, don't get caught up on the
Are you
details,
trying to
okay?
save money on gas money or something?
Well, I don't know. They just want to know like how many cars they can take and how few they can take. These are just basic introductory things, so it doesn't make a lot of sense because it's so simple. Once we get into some other stuff, it'll start to make a little more sense. We want to find the least and the most amount. Okay?
I feel like if you're like trying to take the least, you'd pack those things full.
Yeah, you would.
You'd use more vans and cars, and if you were trying to take the most, you'd use more vans.
Right, logically, when you think about it, definitely you're going to want to try to use more vans, right? But then you got to think, well, maybe the vans get worse gas mileage or something like that. So maybe the car, if you take more cars, it's actually cheaper. I don't know. Right? Things like this But this is just a basic, simple one, so we're not going to overthink it, okay? We just want to find the maximum and minimum number of cars. All right. So we know that a car can take 6 people.
No, a van can take.
Oh, a van can take 6 and a car can take 4, right? Now we also know each team, it says, has 14 athletes and 2 coaches.
It actually says it has no more than 2 coaches and 14.
No more. Very good. So that means at the most it's going to be that, right?
So then greater than or equal to.
Right. We know that this amount here, there's 3 teams in total, 16 people, a maximum on each team. So at the most, this is going to be equal to or less than 16.
So
16 times 3, because there's 3 teams.
we can't
48.
have less than 48 seats because then we won't have enough seats. We have less.
That's the maximum amount you can have. Because it says no team can have more than 2 coaches and 14 players. So it can have less than that. But at the very most, you can have 48 altogether. Okay? This is where it gets a little tricky with your signs, okay?
Yeah, you can use all the cars in the car good.
It's gonna be solid, isn't it?
Why is it?
This would be a solid line. Good.
Where'd you get 48 from?
Because there's 3 teams. Okay? Yeah. There's these little details you gotta be watched for, okay? Now, how many cars in total? What's the maximum amount of cars they have?
12 cars, 4 minivans.
Right, so we know that the cars is going to be less than or equal to 12. And we know the vans, how many vans are there?
4.
4, good. Okay, that's all the information I've been given now, okay? So I would graph with this. Now, the other thing you need to find is the objective function. And the objective function finds your max or min value. Okay? Max or min, not max or min. All right, and what are we trying to find here? The maximum amount of vehicles, right? Or the minimum amount of vehicles.
And the maximum?
Yeah, it says here find the maximum and the minimum amount of vehicles. Normally you just need to find the minimum or the max. Okay? So to find the vehicles that you're going to be taking on the trip, all you're going to do is you're just going to add up what you're taking, right? There's nothing really else to it. So your vehicles just equal x plus y. Now your objective function might not always be this simple of just x plus y, but it'll always be like an equal sign. There's no greater than or less than part to it, okay? All right. Little confusing still?
Is this the end of it?
No, now we're going to graph it. Okay? This should be weird at first. This is the first time you've seen this, okay? So don't feel like you guys should be understanding everything totally, but hopefully you guys understand where I got these equations from. Yeah?
Do you have to write all 3 equations every time for 4?
Yes. Yeah. Sometimes there'll be more, sometimes there'll be less. Okay? It all depends on the information in the question, okay? Yeah. I know. From grade 10 to grade 11 math is a bit of a jump. So, surprise. All right. All right, so I'm going to graph these questions. All right. Now, because I'm dealing with vehicles, I can't have any negative values, so I'm just going to use one plane here like this.
So you just do it the same, so like, if x equals 0, y equals,
Yes.
and then that's 0. Okay.
Yes. Okay. Whoa. Stop it. All right. Okay. Now, here's my plane. So my first equation was x is less than or equal to 12. Okay. So this here is just a vertical line through x equals 12. All right. And because it's greater than and less than, is that solid or dotted?
Solid.
You were going to say it, weren't you? You were going to double check, though. I like it.
Solid.
That's good enthusiasm for the first day back on a Monday after a break.
Yeah.
Good, so I'm going to draw a solid line right here.
I was right. You're wrong.
I was also right. I said it before you, so I vote I was right.
Henry, you're wrong.
I was
Very-
right.
Guys.
Okay, now, x is less than 12. So which way would I shade? Would I shade everything bigger than 12 or everything smaller than 12?
Bigger.
Yes.
X is less than 12?
Bigger is better.
So,
Yeah.
like towards zero.
Right, you're going to everything smaller than 12. This way.
Nice shading, bud.
Well, I don't want to overcomplicate with a lot of lines.
So,
Yeah.
right on 12. Are you gonna explain this now?
What do you mean?
Like what happened?
Well, like I'm shading, right?
Yeah.
So Jenna.
Those are all the numbers that are.
Yes, these are the numbers that it could apply to. Because Jenna, what is my equation here? Say x is smaller than 12, right?
Or equal to, so then you could go 12.
That's why the line shape.
Good.
That's why the line's solid. And everything smaller than 12 I shade towards, right?
Why couldn't it be dotted?
Because if it's dotted, then it has to be x is greater or less than 12.
I know, that's what I think.
You haven't done 6.3 or 6.2, have you?
I might have not.
Okay, my next line. Y is less than 4. So that's a
Equal to or less than. It's like
right. So it's going to be a solid line again.
I'll bring it in.
Right here.
I will.
Now everything less than 4. So do I shade above 4 or below it?
Below it.
Below it.
Good.
So then you erase what you shaded over the top?
You don't have to. You don't work with that. You just work with the area that's been shaded together. All right? Now what you also want to do is you want to label the points where the lines intersect. So the lines are crossing there, right? That points at 12 and 4. All right. Now, the last line I have to draw is 6y plus 4x is less than or equal to 48. Do you guys remember how to graph these ones? X and y intercepts, you make one 0 and solve for the other one, and make the other one 0 and solve for the other
So
one.
8, 12. Or 12, 8. Oh, so it's going to be.
Is it 12, 8?
Yeah.
If this is 0, yeah, that's 8, 12. Okay, yeah. So,
Y equals 8.
right. You guys want me to go through that?
Yeah.
Okay. So
Is this like in like what we were doing in like with the 0, 0 almost?
yes.
Okay.
All right. So I'm gonna write it down here just so I can scroll up. 6y plus 4x. You don't have to rewrite it. I'm just gonna write it down here so I can show my work. All right. So first thing I'll do is I'll make y equal to 0. Okay. So this will be for my y-intercept. So if I do that, I'm gonna have so now I can just have 4x is greater than or equal to 48. So I divide both sides by 4, right? So this is 0, it's gone. X is 12. So my first point is at 12, 0. Yeah, I got to do it for the second point now. Now for the next time I do it, I make x equal to 0. Okay. Is this kind of, yeah? Good. What?
If the point sign is 0, 0, Like his PowerPoints that are accepting lots of.
No, it won't go through 0, 0, but I make one 0 and I solve for the other one. Right? Like I made y equal to 0 and I solve for x.
Yeah, but I thought that's because it was just like.
Oh, no. I'm finding the intercepts, like where it crosses the x and y axis, and then I connect the dots. Sorry, Brooklyn, I misunderstood you there. Okay, so 4 times 0 is just 0. I divide both sides by 6, right? Am I going too fast?
No.
Okay.
Well, I've done this formulas like this, so.
Yeah.
Yeah, just get to 80.
Minus 4. Negative 7.
Divide both sides by 6. 8. So my other, or my y-intercept.
Am I supposed to show my work?
You don't need to, no. I'm just doing this as a quick review, first day back.
Okay, sorry, I was like, I haven't shown my work, like, in a long time.
No, you don't need to. Just be careful. Like, if it's all wrong, then I can't give you part marks, right?
Yeah.
Alright, so let's draw this one out. So 1 point is at 8 and 0. The other one's at 12 and 0. And it's a solid line as well.
And then you shade towards 0 because it is less than 48.
0 and 0 would be less than 48. That's true, yeah. So you would shade. Yeah. So if I put 0 and 0, I'll go through that with you guys. So now I need to know which way to shade. And remember, as long as the graph doesn't pass through 0, 0, you put that point in and you see what happens. So if I put 0 and 0 in here.
It's gonna be true.
Right, it's true. Good. Excellent.
Then you shade.
Towards, yeah.
So now we're gonna work with that little itty bitty square.
So this part here is what I care about. Okay, I'll shade that in black.
Are we done now with the graph?
Nope.
I shaded my next one too dark, now I can't shade darker.
Okay,
There's no blue in that. It's kind of blue.
it's fine. There's a little bit of blue. What are you talking about? You just gotta look for it. You gotta really want it there. All right. Now, remember your points of intersection. This one just worked out really nice. That's at 8 and 4.
Usually do you have to put decimals in that?
You might have to at sometimes. That's like to find out for sure. You should put like, because you know this is at 4. Y is at 4. So if you put 4 into here, you can check to see what your other value is going to be. Okay. Oh, and you know what? That's totally wrong. That should be 6 and 4. That's,
Yeah, I was right then.
yeah, sorry, I just drew it wrong. To do your check, like you should put, like if I put 4 into here for Y.
Has anyone said it's perfect?
Yeah. 0, you're wrong. Incorrect.
We solve this.
I know. Sam texted me. No, 10:30. Just kidding. But it was
No.
Could we just redo the first lesson we did instead?
No, we gotta. I knew this was gonna happen with everyone gone last week or 2 weeks ago. We gotta keep
I'm
going.
fine.
I'm not.
6 and 4.
Totally
I'm not fine.
When are you ever fine?
How did your line not match up with
In the summer.
Because I look at how I draw things. Like look at my scale here's like this, and then over here it's like all over the place. So use the grids that I provide over there, or do a check to make sure. Okay. So then you look for your points of intersection that are in the shaded zone, and these are what you'll use, okay? So it's either going to be 6 and 4 or 12 and 0. All right, so the minimum amount of cards you could take would be 10, right? You add them up. Or 12, okay? You just plug them in. So then all you do in the end is you take your intersection points and you plug them in to your objective function and see which one comes out biggest and which one comes out smallest. Okay?
You know Miss Lee is back from China?
Yep, she is. She is here today.
16 can be.
That's what I did in my head 20 minutes ago.
Oh, it just takes time. All right, I'm going to do one more example with you guys, and then I'm going to give you some small ones to try out today. Ease into it. Ease into it. Open your textbooks, go to page 327. This is example number 2.
Same place, so. Just like all these natural ones.
How long is this gonna take?
Oh.
This one here, hopefully for 10 minutes.
Well, yeah.
It's gonna take
I
like.
don't have the breakfast.
No.
Whatever he says.
Well, this one might because you're going to have some questions.
Maybe some of these.
Okay. A refinery produces oil and gas. Okay, like an oil refinery, like the one in Regina or Lloydminster. At least, okay, so I'm going to break down, give you the information, then we'll talk about it. At least 2 liters of gasoline is produced for each liter of heating oil. The refinery can produce up to 9 million liters of heating oil and 6 million liters of gasoline each day. Gasoline is projected to sell for $1.10 per liter. Heating oil is projected to sell for $1.75 per liter. The company needs to determine the daily combination of gas and oil that must produce a maximum revenue. Create a model that represents the situation.
I got this.
Yes.
If you produce at least 2 liters of gasoline for every liter of heating oil, why do you produce more heating oil than gasoline in a day? What do you do? Stop making gasoline after?
No, that's how much they can make. It doesn't necessarily mean they will make that. Okay. These are all the constraints you have to think about. Okay, Emery.
But why would you be able to make more heating oil than gasoline?
Just how the refinery process works. What they do is they put it all in one big vat, and then it separates, right? And for how it separates, for every 2 liters of oil, for every heating oil that separates, you're going to get 2 liters of gasoline.
Is it different separators?
I believe it's all in the same one.
If it's all the same one, that still doesn't make sense then.
Well, no, just how it separates from the
If it's one
the crude
big
oil.
vat of separator,
yeah.
you should produce at least double the amount of gasoline in it than heating oil.
Yes.
This doesn't.
I can't remember the details of going into the chemistry behind it, but like it separates itself, and there's different vats. I believe there is different vats for different things. Okay.
Okay.
All right.
And
And think about it. What are you going to sell more of, more likely in the real world? Heating oil or gasoline?
A lot of both.
Yeah, but probably more gasoline, right? Most people don't use heating oil to heat their homes anymore.
If you produce more gas, why do you produce more heating oil in a day?
I don't know, Emery. That's just the question, okay?
Okay, well they need to make.
All right.
That actually makes sense.
Either way.
25 minutes.
Okay.
I'm trying to do the work.
It's okay. I don't know much.
Not there.
Okay, so I'm going to make X gas.
So what do you think about your suggestion?
Yeah. That is why. What does that say?
Heating oil.
Heating oil.
Oh.
Thing.
Yeah, for the E it's an R.
It's an E.
Karate.
Okay.
And the end is also an R.
Crying.
So I'm going to do constraints first. All right, so
There's nothing wrong with that.
No, I think it's
What oil?
heating oil.
What does heating oil do? I definitely asked you this last semester.
before everything was connected to natural gas, they'd come along and people would burn oil in their furnaces instead. So you'd have a tank on the side of your house and like a co-op man would come by and fill it. Yeah, it used to be the co-op. Because they have the refinery and everything.
Wait.
Like a co-op.
Something, but instead of milk, it's oil.
So when you put constraints in the first equation, for example, you didn't mean like seatbelts?
No, constraints are the lines you're going to draw. Okay, so my first one, I know I can produce up to 9 million liters of heating oil a day, okay? So gas, X is going to be less than or equal to 9 million.
Gas is 6 million.
Oh, sorry, I got them backwards.
Okay. I'm just like, what kind of person did
Wait, what?
Okay, so my first constraint, guys, pay attention, please.
Sorry.
My next one is heating oil.
I have a question, is that
I never
six, 0, 0, 0, 0?
Oh, there, 6 million.
Yeah. I mean, that's this one.
I erased one of the zeros.
6.
Okay,
There's no X's.
there's my first two. All right, quick, pay attention to this part. This is what everyone gets tripped on. The next one.
I'm tripped up right now.
When I say,
Is this Regina?
it might be, or Lloyd,
Mr. Weber, thank you.
or Alberta, I don't know. We'll say it's Regina, because it's probably the closest refinery here. Now, at least 2 liters of gasoline for every liter of heating oil. That means if I produce 1 liter of heating oil, how many liters of gas do I produce? 2.
So
At
we have
least 2. You
40
could produce 4 though.
liters of heating oil, and you have 80.
40, yeah, every time I make, let's say 10 liters of heating oil, I'm going to double that into gas,
At
right?
least double.
Right.
You want gas.
What's that? At least. So what that means is
X times 2 equals what?
2x is going to be greater than or equal to, because it's at least y. Okay? My gas is going to be at least twice as much as my oil.
No, I can't.
Okay?
Just a little bit.
It's probably a typo, Emery, but I'm not going to go back. They probably meant to put twice as much gas to oil, but
Okay.
let's just leave it,
What
okay?
did they put?
What if it doesn't work?
It'll work. I've done this example a lot. It
What
works.
did
You
Okay?
say no one's ever asked you that question before?
I don't think so. I don't know. Okay, now, yeah, I know they're gonna have like a 30-minute video.
No, it's okay.
It's actually 28 minutes right now.
It'll be. All right, so let's. Okay, now I need my objective function. Right, this is the max or the min that I'm trying to find. The question's asking for the maximum amount of oil,
The maximum.
Jackson gonna have to watch this.
maximum revenue. Yeah, he is.
Oh, that's.
I'm not gonna say.
Hi, Jackie.
Yeah, everyone say hello to Mr. Furby.
Hey. I don't think he's gonna respond, but that's okay.
Could you just do that by just timesing 9 million by the heating oil number,
He might not even
and
watch
then
this video.
Sure, glad
6
Jackson's
million
gonna
by the
do
gas number?
No, because you got to figure out the perfect amount, right?
Well, wouldn't that be, if then you add them, wouldn't that be the maximum amount you could actually do?
Well, where it's gonna get
Whoa,
tripped up,
whoa,
Emery, is right here.
Whoa.
This is gonna change everything, okay?
Every environmental.
That's your objective function.
it.
Remember your max or your min. The
Environmental,
question
that's
says,
what Tristan has.
what amount of gas and heating oil will give me my maximum revenue?
Let's
So I take the liters of oil and the liters of gas that I make, I times it by the price, and that's gonna give me, when I add them up, my maximum revenue. Alright? So now we'll graph this one again.
looking at a Blair calculator.
Are you gonna label the axes?
Yeah.
I don't think that's right.
What's wrong with what I'm doing?
Is it called axes or axes?
Axes.
That's what I meant when I said that.
That's my third.
Like it's not cactuses, it's cacti, right?
Yeah, but it's not cacti.
Wow, same thing. Like radius isn't radiuses, it's radii.
So it is cacti or axi.
Axes.
Okay.
Like it's not matrices or matrices, it's matrices.
What?
Oh yeah, we don't teach
Matrix.
We don't teach matrices anymore.
Okay, bro. Let's get down to business. First things first. I don't even know factory of 6, so I don't think I can start with 6 times what? No. What times 1 has a square?
Okay, so once again with the word problems, you don't have to draw in the negative coordinates. So my first one, x is less than or equal to 6 million. Just so you know, these are in millions, okay? So my first one.
So talk about your data. Distracted.
Now it's a solid line because it's less than or equal to. Now because it's less than or equal to, do I shade towards the 0 or away from 0? It's less than.
Oh wait.
No, you go towards. It is
Towards, right? My next line, y was less than or equal to 9 million, right? Like that. Once again, I shade towards the 0.
Right now. Yeah.
Now my next one, 2x is greater than y, greater than or equal to y. So what that is, it's going to be a straight line. It's going to cross through 0, 0 right here. All right, and for every x value I put in, what happens to my y value?
It's bigger.
It doubles, right? So if x equals 2, what's my y value going to be?
4.
Right, so if x is 2, y is 4. Right, like that.
Oh yeah.
Oh, really good. So which part do you shade?
Then you got to check. We can't use 0, 0 now. If we put 0, 0 in, it won't work because the line crosses through 0, 0. Remember I said you have to pick points that the line doesn't cross through? So if I were you, just take one over here, like go 0 and 1, and plug that in.
You know what? Why is
Does that make sense? Just pick a point anywhere on this plane that doesn't cross the line. 0, 1 right here doesn't touch the line, so I can use that one. Pick something small and easy to work with. All right, so if I plug that in now.
We've never plugged in one with the actual number.
Well, would you just do it? So I said the point is 0, 1. So if I plug that in, 2 times 0 is 0 greater than or equal than 1?
No.
No. So I'd shade away from this one, and I shade on this side of the line.
It is.
0 is actually a bigger number than
What's that?
What is
See,
that?
you already threw him off. All right. So here are my points of intersection.
I had it until, somebody made it wrong.
Messed it up. Sorry, I know
I know this one is at.
My initials aren't IS. It's definitely not IS.
Is the other one 4.9 or is it 5.9?
That one is at.
That's
It's
6.4.
That's a 4.
You think so?
I think it's a 4. Cars are not.
I think it's a 4 as well.
Oh, I meant like you wrote it like a 4.
Oh, I see. Very
Oh,
nice.
it's like up at the.
All right, then you just plug those in to your objective function over here, and you see which one would give you the biggest value.
Another one.
Just by looking at them, can you tell me which numbers are going to be bigger?
6 and 9.
6 and 9.
Yeah, totally.
Because
I can't sit here.
there it is. Okay, so for you guys to try today, go to page 330,
The pink one.
do 2, 3, and 4.